Okay, so now that we have kind of a base understanding of how to solve equations using our golden rule and getting x by itself, and covering one and two step types of equations, we're now going to move into section 2.2 where the complexity is going to get a little bit more. So we're talking multi-step equations. So at this stage, we definitely need some sort of a game plan on how we're going to approach it. So let me talk you through the game plan, and then I'll show you some examples, and then we'll steadily get harder, and we'll just keep adding to the complexity. But when you have a really difficult equation to solve, the first thing you actually want to do is go back to chapter 1 and use the idea of simplifying both sides as much as possible. Remember, on both sides of an equation are two expressions, and so expressions can be simplified. So to help us make sense of the problem and start understanding what we want to add or subtract or multiply and divide, let's take the time to actually simplify both sides as much as we possibly can. Also at this stage, you can clear fractions or decimals, and I'll show you how to do that a little bit later on. Once we've simplified both sides as much as possible, the next thing we want to do is start using our golden rule. We're going to add and subtract to collect like terms to either side of the equation. Oftentimes students like to collect the variables to the left side and non-variable stuff to the right side, but it actually doesn't matter. You can collect it either way. An equality is an equality whether it's left or right, but standard operating procedure, I usually have students collect things to the left. And then once we've done that, we're golden rule away of a multiplication or division to get x by itself. And usually by that time we have our solution. And of course, step 4 is you can actually check that solution by plugging it back into the original equation and seeing that it works. Or for you guys, you'll probably just look in the answer in the back of the book and say, yeah, I got it. All right, so we're going to see a lot of this game plan. Let me start off with some relatively simple examples. All right, so the first one, I have 8x plus 3 is equal to 5x minus 2. So as opposed to what we saw in 2.1, what makes this one a little more difficult is the fact that we have the variable x on both sides of the equation, not just on one, like in a one or a two-step problem. So we have to basically address the fact that we need to move some things around. Again, following my game plan, the first thing we need to do is simplify both sides as much as possible. But when I look at this, right, 8x plus 3, I can't simplify that anymore because there's no like terms. Same thing with 5x minus 2. I can't simplify that anymore because there's no like terms. So as far as step 1 is concerned, we're finished. We've simplified both sides as much as possible. So on to step 2, where we start doing an addition or subtraction. So the golden rule, I'd like all my x's usually to be over to the left. So what I'll probably do is subtract 5x from that side. Of course, the golden rule says whatever you do to one side, you have to do to the other. And so I'm going to subtract 5x from both sides. I can do two things at once. As we collect my variable x's on this side, anything without x we can collect to the other side. So I could also be subtracting 3 from both sides. So again, I like to show my balancing act vertically. You could have done this horizontal if you wish. But if we go through this, 8x, take away 5x, gives us a 3x, and a plus 3 minus 3 goes away. Don't forget your equal sign, right? Because our equal sign follows. 5x's cancel out, a minus 2 and a minus 3 gives us a minus 5. So we've just finished step 2 of our equation solving multi-step problem. So we use the golden rule of addition and subtraction to collect like terms to one side. And now you can see we're basically at step 3, we're one golden rule away, where in this case maybe we divide both sides by 3. Right? The 3's will divide out, and we get x equals negative 5/3. And there's basically our solution. If I wanted to check it, I'd go back to the original equation. I think it was this guy right here. Replace that x with negative 5/3, and we'll find that we get a true statement. But I'm just going to concentrate on the first 3 steps because that's really the most important part at this stage of the game. So again, what makes this more challenging is I have x terms on both sides of the equation and non-x terms on both sides. So we have to begin by simplifying both sides as much as possible, using our golden rule of addition and subtraction to move some terms around, and then we're usually just a golden rule away of multiplication or division to finish things off. So let me do one more example. Right, this one we have negative 3 times the quantity 2x minus 5, and it's set equal to 5 times the quantity 2 minus x. So again, there's a little bit more going on in this one, though we definitely have to start with step 1, where we simplify both sides as much as we possibly can. So I'll begin by doing a distribution. So if I distribute a negative 3, right, a negative 3 times a 2 would give us a negative 6x. Right, a negative 3 times that negative 5, if you would, remember that's a plus negative 5, would give us a positive 15. So 3 is tripling everything, and the negative changing all the signs. On the other side, when we distribute, we get 10 minus 5x. So in terms of simplifying, we're done, because we don't have any like terms on this side, we don't have any like terms on this side. So both sides are as simplified as they can be. So our next move is to start moving some terms around. Again, you can move things any way you want. I'm going to go ahead and continue. Again, most students like to move things over to the left. So I need to basically, right, this negative 6x is in a good spot, but this minus 5x, right, I don't want it on this side of the equation. So how do I reverse the addition of 5x? We add 5x, and whatever I do to one side, I do the same thing to the other. As I'm moving that, I can be taking this 15 and moving it to that side. So again, how do I undo the addition of 15? I subtract 15. Whatever I do to one side, I do to the other. So there's my balancing act. There's my step 2 where we're adding and subtracting. Finishing this off, when I combine like terms, a negative 6x and a positive 5x leaves us with a negative x, and the 15s will cancel out. 10 take away, oops, don't forget your equal sign. 10 take away 15 is negative 5, and then a negative 5x and a 5x, they cancel each other out. So basically, we've now collected my like terms. So step 3, we're a multiplication or division away. What I have is a negative x, so perhaps if I multiply both sides by negative 1, that'll get the trick done. A negative times a negative is a positive, and a negative times a negative is a positive. So our solution to this equation is 5. And then the idea is if we go back, I believe the original equation was this equation. If I go and replace this x with 5, I should get a nice true statement. So that kind of gives us a quick intro. Obviously things are going to get much more difficult, but this idea of simplifying both sides as much as possible, using an addition or subtraction to start collecting like terms to one side, and then we're usually just a multiplication or division away from getting x by itself. Alright, so we'll add on to the complexity in the next couple of videos where this little game plan is going to become extremely important. See you guys in the next video.